What if the universe just whispered something it was never supposed to say? In the silent darkness beyond Neptune, beyond the last familiar boundaries of our solar system, an object appeared. Not born here, not moving like it should, not behaving according to any equation we trust. NASA cataloged it with a sterile name, 3IATLAS, the third known interstellar visitor ever detected passing through our cosmic neighborhood. But behind that harmless label lies a question so disturbing that some physicists hesitate to say it out loud. Because according to publicly released trajectory data, spectral readings, and motion analysis, this object does not fully obey the rules that govern everything else in the universe. Not gravity as we model it, not momentum as we teach it, not even probability as we understand it. And if that's true, then this isn't just an anomaly in space. It's an anomaly in reality. For centuries, humanity has believed the laws of physics were universal, unchanging, absolute, and written into the fabric of existence itself. From the Big Bang to the death of stars, from atoms to galaxies, everything was supposed to follow the same cosmic script. But 3IATLAS appears to be improvising. NASA scientists are careful with their words. They speak of non-gravitational acceleration, unmodeled forces, data inconsistencies. But history has taught us something chilling. Every time science encounters data it cannot explain, one of two things happens. Either the anomaly disappears, or the worldview collapses. Copernicus shattered Earth's centrality. Einstein broke Newton's universe. Quantum mechanics dissolved certainty itself. So now, as this object cuts silently through interstellar space, one impossible question hangs in the void. What if the universe is not as stable as we thought? What if the laws of physics are not laws, but habits? And what happens when something arrives that never learned them? Because if 3IATLAS is real, and the data suggests it is, then the universe just blinked. And we might be seeing what's behind its eyes. To understand why 3IATLAS has unsettled scientists, we need to rewind the cosmic clock. For most of human history, our solar system was believed to be a closed neighborhood. Planets formed here. Comets belonged here. Asteroids were leftovers from our own creation story. Nothing was supposed to arrive from outside. That assumption shattered in 2017 when astronomers detected Oumuamua, the first confirmed interstellar object ever observed passing through our solar system. It had no visible tail, no clear coma, and yet it accelerated as it left the sun. 2 years later came 2I/Borisov, another interstellar visitor. This one behaved more like a traditional comet, reinforcing the idea that Oumuamua might have been an odd but explainable outlier. Science exhaled. Interstellar objects, physicists concluded, are rare, natural debris, ejected during planetary formation around distant stars, wandering the galaxy for billions of years before briefly intersecting our path. Harmless, random, understandable. Then came 3IATLAS. Detected by the Atlas survey, designed to spot threats to Earth, this object immediately raised eyebrows. Its incoming velocity was unusually high. Its trajectory suggested an origin not just from another star, but from a region of the galaxy where models predict almost no ejecta should survive. Even more unsettling was its timing. Our detection capabilities have only recently become sensitive enough to spot such objects, which raises a quiet, uncomfortable question scientists don't like to frame directly. Are interstellar visitors becoming more frequent? Or are we only now starting to notice what has always been passing through us? Because if objects like 3IATLAS are common, then our solar system isn't isolated at all. It's a hallway, and hallways imply traffic. At this stage, nothing about 3IATLAS should have triggered alarm. But then astronomers ran the numbers again, and something didn't add up. Here is where the story stops being comfortable. When astronomers plotted the trajectory of 3IATLAS, they expected something routine. A clean hyperbolic path. Gravity in, gravity out. Newton's still intact. Instead, the data began to drift. Subtly at first, then unmistakably. 3IATLAS was accelerating, but not in a way that could be fully explained by gravity alone, not from the sun, not from planets, not from any known massive body. NASA's internal reports use a careful phrase, non-gravitational forces. On paper, this sounds mundane. Comets do this all the time. As ice sublimates, jets of gas act like tiny thrusters, altering their motion. But here's the problem. 3IATLAS showed no clear signs of outgassing. No visible tail. No significant coma. No spectral fingerprints of water vapor or carbon compounds in expected quantities. Yet the acceleration was real. Measured. Repeated. Cross-checked. Some physicists attempted to model exotic ices, hydrogen ice, nitrogen ice, ultravolatile compounds that sublimate invisibly, but these explanations strain credibility. Such materials should not survive the radiation, collisions, and timescales required for interstellar travel. Others noticed something even stranger. The acceleration wasn't constant. It changed with orientation, almost as if the object's geometry mattered. That alone raises an uncomfortable implication, shape-dependent dynamics at a scale where they shouldn't dominate. Which brings us to the quiet sentence buried deep in technical discussions. Current models fail to fully account for the observed behavior. In science, that sentence is radioactive, because it means the equations, the ones that work everywhere else, break here. Not dramatically, not explosively, but just enough to matter. And when physics breaks, it never breaks locally. It breaks globally. So now the question is, what is 3IATLAS? It's far more disturbing. What if our laws of motion are incomplete? And this object is exposing the gap. When data refuses to cooperate, science does something very human. It hesitates. Publicly, researchers emphasize restraint. They remind us that anomalies often dissolve with better instruments or revised assumptions, and they're right, most do. But privately, speculation begins. Because if conventional physics cannot explain 3IATLAS, then only unconventional ideas remain. One possibility physicists quietly debate is unknown physics of matter, forms of material that interact weakly with radiation, structures whose internal dynamics we don't yet understand, matter that responds to forces we haven't fully mapped. Another idea goes further. What if the object is responding to pressure from spacetime itself? Not gravity, but gradients in the fabric of the universe we don't usually notice. This drifts into territory normally reserved for theoretical journals and late-night conferences, modified inertia, emergent gravity, or physics beyond Einstein, frameworks where motion is not purely a response to mass, but to information, geometry, or vacuum energy. Then there is the theory scientists almost never say out loud. Artificial origin. Not as a claim, not as a conclusion, but as a boundary case. Because if an object changes its motion without visible propulsion, if its acceleration correlates with orientation, if it behaves more like a system than debris, then physics must at least ask the question. Not is it technology, but would we know the difference? And that question is deeply unsettling. Because our detection methods are built to recognize natural patterns, we assume nature is simple, indifferent, and repetitive. But what if something passes through our system that was never shaped by our assumptions? NASA does not claim this. No agency does. But the absence of an explanation does something powerful. It forces open doors we worked very hard to close. And once opened, they don't shut easily. So now, hovering between the stars, 3IATLAS exists in a dangerous category. Not proven, not dismissed, not understood. A question mark moving at cosmic speed. Let's assume, just for a moment, that the anomaly holds. That future observations don't erase it. that improved models don't smooth it away. That 3I atlas continues to behave in ways our equations cannot tame. What would that actually mean? First, it would mean the laws of physics are not closed, not finished, not universal in the way we've believed since the Enlightenment. Physics, as we teach it, rests on a dangerous assumption that the same rules apply everywhere, at all times, without exception. That assumption is what allows us to extrapolate from Earth to stars, from laboratories to galaxies. 3I Atlas challenges that leap. If an interstellar object can enter our solar system carrying behavior that doesn't quite belong here, then physics may be context-dependent, local, environmental, shaped by histories we don't share. That alone would rewrite cosmology. It would imply that the universe is less like a machine and more like an ecosystem. Different regions, different conditions, different rules emerging from deeper layers we haven't seen. Second, it would force a reckoning with how fragile our models really are. Every spacecraft we launch, every trajectory we calculate, every prediction we trust rests on the idea that motion is solved, that gravity plus known forces are enough. 3I Atlas suggests they may not be. And finally, there's the psychological impact. Because humanity has always believed that by understanding the laws of nature, we understand our limits. But what happens when something arrives that plays by rules we never learned? Not hostile, not benevolent, just different. That realization doesn't threaten us physically. It threatens us epistemologically, our confidence that reality is readable. And once that confidence cracks, curiosity turns into something heavier, something closer to unease. Because the universe may not be hiding from us. It may simply be deeper than we imagined. There is a deeper reason 3I Atlas feels unsettling, and it has nothing to do with aliens or technology. It has to do with meaning. For centuries, science has offered humanity a bargain. The universe may be cold and indifferent, but it is predictable. Know the rules and the chaos dissolves. 3I Atlas threatens that bargain. Because if the anomaly is real, then the universe is not just vast, it is layered. And we may only understand the shallowest layer. Imagine a reality where what we call laws are merely statistical regularities, patterns that hold most of the time but not always, like traffic flows that usually behave until something enters the system that was never part of the design. In that universe, certainty is local. Knowledge is provisional. And understanding is always incomplete. Some theoretical physicists already work within this framework. They speak of emergent laws, where gravity is not fundamental, but arises from deeper informational structures, where spacetime itself is not the stage, but the product. If that's true, then 3I Atlas may not be violating physics at all. It may be obeying deeper rules we haven't discovered. Rules that only become visible when something crosses between cosmic environments. And that idea carries a quiet horror, because it suggests the universe is not obligated to make sense to us. That our equations work not because they are true, but because they are useful approximations, good enough until they are. 3I Atlas may be a reminder of that boundary. A signal that beyond our comfortable mathematical order lies something less stable, less friendly, less knowable. Not malicious, just indifferent to our need for clarity. And if that's the case, then this object is not a messenger. It's a mirror, reflecting the limits of human understanding back at us. Type next to continue to the next section. At some point, 3I Atlas will be gone. It will continue its silent passage through the solar system, slingshot past our sun, and vanish back into the dark between stars, carrying its secrets with it. No press conference will announce a revolution. No headline will say physics is broken. NASA will archive the data, papers will be written, caveats will be added. And yet, something irreversible will have happened. Because once you've seen an exception, you can never fully trust the rule again. Long after 3I Atlas fades from view, its anomaly will remain, embedded in equations, footnotes, and unanswered questions. A small mathematical scar reminding us that reality does not owe us consistency. And that may be the most profound discovery of all. Not that something strange passed through our system, but that we noticed it. For the first time in history, humanity is sensitive enough to detect interstellar objects, subtle accelerations, deviations so small they would have been invisible just decades ago. Which raises a final, unsettling thought. If this is the third interstellar visitor we've identified, how many came before we could see them? And how many will come after, carrying behaviors we still don't have names for? 3IATLAS may not be unique. It may be typical. And if that's true, then the universe is not a static book waiting to be read, but a living process, constantly revealing that our understanding is provisional, incomplete, temporary. So the real question is, what 3IATLAS is? The real question is this. What else is already moving through our cosmic neighborhood, quietly obeying rules we haven't discovered yet? And when we finally notice the next anomaly, will we be ready to accept what it implies? Or will we look away? Because the universe doesn't change.